So in section 11.4b, essentially it's just reviewing again what we're doing with the elimination method and applying these concepts to some word problems. Your homework packet doesn't have any word problems, but the February 5th exam does. But once we master exactly how to use all these methods, I'm going to introduce some word problems probably next week. So, but in any event, here's the notes for this section. And I'll probably refer to them again next week sometime when we do some of the word problems, some of the examples here. So if you are solving linear systems using the elimination method that also involves multiplying, then you're going to have to decide which variable to eliminate. You're going to have to multiply one or both equations. And we're doing this right now in our homework packet. So multiply one or both equations by a constant, so that adding or subtracting the equations will eliminate the variable. Solve the systems using the elimination method. So here's a word problem that uses systems of linear equations to determine the answer for x and y. So the sum of two angles is 180 degrees. So we'll call one angle basically angle x. The other is angle y, and when you add them together, basically x plus y equals 180. Now the difference between twice the larger angle and 3 times the smaller angle is 150. And we're going to say x is the larger angle, y is the smaller angle. And the second part of our equation is, let's see, twice the larger, so 2 times x plus larger and the difference, so difference means subtraction, and 3 times the smaller angle, 3y, is equal to 150. So now we have a situation where we can use the elimination method to determine, the solution of this equation. So we're being asked to find actually what the value of x and y is, and they've given us essentially two conditions. One condition is x plus y is 180, and the other is that twice the larger angle and the difference of 3 times the smaller angle is 150. So let's multiply this top one by 3. If we multiply everything by 3, we'll get the y's to cancel. So I'm going to rewrite my equation here. 3x plus 3y is equal to 180 times 3. And I think that is 540. Now I can scratch that out. Add these together. 2x and 3x is 5x. The y's are going to eliminate, and 5x is equal to 690, which will make x equal to 690 divided by 5, which is, let's see, 138. So if x is 138, and x plus y is 180, then basically 138 plus y, that's a 0, is also equal to 180. Subtract 138 from both sides, y is equal to 42 degrees. So here's an example word problem solved using system of linear equations. So let's go on to the next example. This second example is similar to one you might find on your SAT exam. There's probably 2 or 3 problems using system of linear equations that are a lot like this. So solving important problems that affect the world, like bagels and donuts. So we've got James bought a total of 40 bagels and donuts for the morning meeting. Looks like James wants to get a raise, look good in front of his boss. But we need to figure out how many bagels and donuts he bought. So if he has bagels, he has donuts, if I could spell. All right, I'm going to call bagels B and donuts D. And we know that combined, he bought a total B plus D was equal to 40. And the bagels each cost $1.15. And the donuts cost 65 cents. And so if we did basically 1.15 B plus 0.65 D, all of that was equal to how much money James spent for the morning meeting bagels and donuts. So from here, we can graph these two things to find where they intersect. We can use substitution to find the intersection, or elimination, and we're going to try elimination. So to eliminate B or D, for B I'd have to pick a negative 1.15. For D, I'd have to pick a negative 0.65. So let's try the negative 0.65. If I multiply, use a different color here, all of this by a negative, let me rewrite that, by a negative 0.65, and all of this multiplied by a negative 0.65. I'm going to rewrite my equation down here. I'm going to get negative 0.65b plus negative 0.65d is equal to 40 times a negative 0.65. That is equal to negative 26. So now that I've rewritten this one, I'm scratching it out so I don't make any errors. And I'm going to add these two things together. The D's are going to eliminate. And then you can have basically 1.15 minus 0.65. That's going to be 0.5b, or half a b, is equal to 3350 minus 26, which is 750. I'm going to divide both sides by 0.5. B is going to give us the total number of bagels. So we bought 15 bagels, and we know that bagels plus donuts was equal to 40. Then 15 plus D was equal to 40. So D was equal to 40 minus 15, which is equal to 25. So 25 donuts, 15 bagels.